Hi students, welcome to this video, and today we are going to be working on writing and solving inequalities from a word problem. So you already know how to solve inequalities and graph them, and now you're going to learn how to write the inequality from a word problem itself. So the question I want to ask you is, what happens when there's more than one numerical value of x? So maybe we have a range of numbers. For example, let's say I want to buy 3 apples, but I only have $10 to spend. That means that the cost of the apples could be anywhere between $0 and $3.33, right? Because that's how much each apple could cost and still be within $10. So that's just an example. There's lots of other examples like that. So in this lesson, we're going to learn to create an inequality given a word problem by using algebraic reasoning. So that's just a fancy way of saying we are going to create an inequality from a scenario, and we are going to use our math skills. So let's review really quick. A variable is a letter or symbol that represents an unknown number, or, this is important, set of numbers. Okay, so variables, some popular ones we use: X, Y, you could use a smiley face, you could use a star, so that's where the symbols come into play. Let me draw a star for you. There's my star. Either one. So any one of these is an example of a variable, and it could represent an unknown number, or in this case today, a set of numbers. So an inequality, as we know, has more than one solution. Here's an example. We could have something where x is less than or equal to 3, right? And that would mean that any number that's less than or equal to 3 is considered a solution. So for this, we have a solution set. So it's a little bit different than our equations where we end up with x equals something, or we only have one solution. With an inequality, we're going to end up with more than one solution. Let's review. So remember, for inequalities, we have less than or equal to, we have greater than, and we have greater than or equal to, right? So at least is a really common verbiage for greater than or equal to. So greater than or equal to, this is at least. Okay? At most is less than or equal to. And that, I'll explain scenarios for both of those. So if you only want to spend, like the example I just gave, you only want to spend $10, I would say that whatever the cost of an apple is, so 3 times the cost of an apple, needs to be at most $10, right? If I want to buy 3 apples for $10, then whatever the cost of the apples is has to be less than or equal to 10. So that's just an example. No more than means less than or equal to. So that's another way to say that. At most, or no more than. More than is pretty straightforward. That's greater than. So this is more. Oh, that was a weird line. Let me fix that for you. And less than means less than. Okay. There we go. So those are our symbols. You should know those words, especially when it comes to word problems, so that you know which symbol to use. I always like to think about the problem. Do I want to spend more than a certain amount? Do I want to spend less than a certain amount? Do I need the scenario to be more than that or less than that? And that can kind of help you to figure out which symbol to use and when. So, a common mistake is not using the correct inequality symbol. So you have to be careful, because if you end up using less than or equal to instead of greater than or equal to, your answer is going to be completely on the wrong side of things, right? So we need to make sure that we know when to use what symbol. So if the value is not part of the solution set, so remember that when we solve an inequality, we end up with a set of numbers as our solution. And if the value is not part of the solution set, then we use greater than or less than. So what this means is my example from before. 3x is less than or equal to 10, right? I have $10 to spend, so I would be okay spending $10. Now, let's say I'm not okay with spending $10 and I want some money back. Then I would use less than, because the 10 is not part of the solution set, if that makes sense. So you use the less than or equal to if the value that we're setting the inequality to is not part of the solution set. But if it is, we're going to use greater than or equal to or less than or equal to. Okay, so here's how we are going to write an inequality to represent a situation. Here's our situation. Debbie has at most $60 to spend on clothes. She wants to buy a pair of jeans for $22 and spend the rest on t-shirts. So here's a scenario that could very well happen to any of us, right? You have this certain amount of money to buy. You know you want to spend some of your money on one thing, and then maybe you want to spend the rest on something else. So she wants to spend the rest on t-shirts. So each t-shirt costs $8. What is the maximum number of t-shirts she can purchase? Okay. So, in order to do this, here are the steps that we need to follow. To write an inequality from a word problem, we need to figure out what don't we know. And we need to represent it with a variable. And then we need to know what do we know, right? So for this scenario, we don't know how many t-shirts she can buy. We do know how much the cost of everything is, and we do know how much money she has to spend. Okay? Then we need to ask ourselves, is there more than one possible solution? And in this scenario, we definitely think there's going to be more than one possible solution. And we need to ask ourselves, what type of inequality sign is needed, right? All important information. So here's the scenario again. What don't we know? Well, we don't know how many t-shirts she could buy. So we are going to let X represent the number of t-shirts that she can buy, right? Or just the number of t-shirts in general. Now this is what we don't know, and here's our variable. What do we know? We do know that jeans cost $22. And this we're calling this a constant value. And the reason that we call it a constant is because that number isn't going to change, right? The number of t-shirts may change, but we know she only wants one pair of jeans, so that value is not going to change. So the next thing we need to know, is there more than one possible solution? Well, yes, because if she just bought one t-shirt and the jeans, she would have extra money left to buy more t-shirts, right? One pair of jeans and one t-shirt together would only be $30. So that would mean that she has another $30 to spend on t-shirts. So the last thing we need to know, we know that jeans plus the shirts can't be more than $60, right? It can't be greater than that because she only has $60 to spend. Jeans and t-shirts could equal $60 because she has at most $60 to spend. So if she got to 60, she would be okay. But we also know that the cost of the jeans plus the cost of the shirts needs to be less than or equal to 60. Now here's where the at most comes in again. So at most means that whatever she spends must be less than or equal to this amount. $60 has to be more than the cost or equal to the cost so that she stays right on budget. So if we know that the pair of jeans is $22 and we know the jeans plus the t-shirts needs to be less than or equal to 60, but we don't know how many t-shirts, right? And we're going to represent t-shirts with X. Now, if ever you see this word per or each, this means multiplication. Or we know that we are going to multiply the cost of the shirt times our variable. Okay, so we're just kind of building our equation here. So if we translate this into math speak, or math sentence, if you will, we know the cost of the jeans plus the cost of the t-shirts, and we know t-shirts is represented by X, must be less than or equal to $60. So here is the inequality that we have written from the scenario. And now we just need to solve it, right? So let's go ahead and solve it. So the first thing we're going to do, we need to subtract 22 from both sides. Then I'm going to be left with 8x is less than or equal to 60 minus 22. So 60 minus 22 is going to get me 38, right? Then we know from solving our inequalities, the last thing we need to do is isolate that x. So what we're going to do is we're going to divide both sides by 8. This will cancel. So x is less than or equal to 38 divided by 8. Now, for the purposes of this, we're going to keep it in fraction form. So x, I know that 8 goes into 38 4 times, right? X is less than or equal to 4, because like I said, 38 goes into 8. We can do this with some long division if we want, right? 8 goes into 38 4 times. I'm going to get 32 with a remainder of 6, right? Now my remainder of 6 is going to get me 6 over 8. So technically, x is less than or equal to 4. Oh, there's that silly line again. Sorry. 4 3/4. We can also put this in decimal form if you want. Here's another format. Either way, in this particular scenario, we can't only buy 3/4 of a shirt, right? So it looks like the most number of shirts that Debbie can buy is 4 shirts. So when you're doing these word problems, you also need to think about the scenario. And does it make sense for her to buy 3/4 of a shirt? It doesn't, really. So in this lesson, you learned to create an inequality given a word problem. You used algebraic reasoning and you learned to solve it. So Make sure to break each inequality down into pieces so that you can create your equation or your inequality, and solve it to find your solution. Good luck with all of your practice, and we will see you soon.